This is Elizabeth Hobbs's presentation for Quantitative Research Methods 2. And the introduction is, so STEM's a big deal. Pretty much at this point, we should all say, duh, right? There's been a lot of focus on how teachers can be more effective in the classroom, whether it's hands-on activities, whether it's modeling, whether it's using inquiry, whether it's exploring the nature of science, whether we're using kinesthetic activities to engage our students, project-based learning. All of those things are overwhelming to a teacher, and it is hard to see the impact overall when many of these students will use science very little in their actual career paths. So extracurriculars have a potential big impact because these are students that are electing to do them. It's usually a smaller group of students. For the teacher, there's no curriculum, there's no grade constraints, there's no pacing, there's no extra work. And then typically student participation is voluntary. And students can have some choice and voice. They choose to be there, they choose what projects to do, and they can guide the path of how they do and what they do, much more than when the curriculum is driven by national standards or curriculum is driven by the teacher. So the theoretical framework that we are using today is social cognitive career theory, and that says that a student's career choices are based on a student's personality, learning experiences, and self-efficacy, with the learning experiences augmenting self-efficacy. Basically, you have a successful experience, you learn from that experience, you gain power, you gain self-confidence, and that sets you up for more positive experiences, and it kind of snowballs from there. You also have some social identity theory, where it suggests that students grow multi-layered social identities based on their group affiliation, and that diverse social context elicit thoughts, goals, and behaviors that are consistent with these constructions. This is kind of the reason why high schools have clubs in the first place. Students find a group that they identify with, and they can create a positive construction of their self-identities with that group. They have peers that allow them to interact, and they can say, okay, well, yes, this group actually fits me, or no, this group doesn't fit me, I'm going to try and join another group. So they create their own identities, and that's kind of what high school's about. And then you've got the expectancy value model of achievement of related choices. And that's a student's decision to persist in taking mathematics and science coursework as determined by his or her personal evaluation of the likelihood of success in and the relative value they have assigned to the options available. So here's the reason why I wanted to do this research. Basically, it's going to see if extracurricular activities are effective in helping students see science as a useful thing for their career. The reason why I want that is because I'm a science fair coach. I do this as an extracurricular activity. And I have seen students who do science fairs and are successful go on to either major in pre-med or major in engineering or major in information technology. And the question is, do they choose that major because they're awesome at science and they choose to do science fair because they're awesome at science? Or does the science club experience and the science fair experience urge them on to choose those paths through these different theoretical frameworks? So it's kind of, are they going to do it because they're awesome, or do they learn that they're awesome so they go ahead and do it? I'm not sure. So the question is, does participation in a science extracurricular activity increase a student's view of science as useful for a career? So the statistical test that I chose was multinomial logistic regression analysis. And what that does is it develops a predictive model through the beautiful magical stuff that goes on in SPSS. And it compares the predicted model results with the actual results. And that's what's called the classification result. The independent variable that we chose was the participated versus non-participated. Did students participate in science club? Did students participate in science fair? Or did students participate in a summer science program? Or are they male or female? Those are all categorical variables. Then we had the dependent variable, which was the agreement on the question if science is useful for a career. And that was ordinal with strongly agree, disagree, or strongly disagree. And one statement on that, it was not, are you planning to major in science or are you planning to major in mathematics? And that goes back to the theoretical frameworks where it is based on students' personalities. So some people really love and enjoy science, but they know that that's not a career path. And I think that's okay as an expectation that not every student who participates in science club is going to be a STEM person. But did they gain an understanding that science is useful for some careers? That's what we're kind of looking at there. So overall, the results, which is in itself pretty interesting, is 6.3% of students participate in science club, 6.1% of students participate in science competition, and there are some questions of did they participate in both or one or the other, and we'll talk about that later. And then also 3.7% participated in summer science programs. A thing to investigate later on that I'm relatively interested in is you can see that for the male and female classifications, for science club, more females than males participated in science club, but for science competition, more males than females participated in science competition. And so for my druthers later on, I'm going to try and figure out if that's a statistically significant difference. And if it is, it kind of buys into my stereotypes that boys are encouraged to participate in more competition-based activities, where girls would be encouraged to participate in more social activities, as in clubs. And then here's also something interesting for male and female participants. It seems that females seem to be more likely to strongly agree and disagree with science is useful for a career, and then males seem to more likely disagree and strongly disagree. And again, I'm going to try and run the stats to see if that's significantly different or not. But those are some cross tabulations that I decided to run. I didn't really touch on my paper, but those are for further investigation. So the meat and potatoes. So the estimated effects on odds of science utility career. So let me back up a little bit. Basically, we're comparing it against a baseline score. So for sex, female is the base category, and then male is the comparative category. I wasn't able to flip them in SPSS. So female would be represented by a 1, and male would be represented by a 0, and typically 0 is the base. But in this case, 1 is the base. Okay? And then the other categories are participated versus not participated. And the base category for those is that participated is considered the baseline and not participated is what we're seeing here. And then for the dependent variables, strongly agree is considered our baseline. And then agree, disagree, and strongly disagree are the results that we're seeing right here. So if overall it is less than 1, it is less like it. It's an odds probability. It's figure it out as a multiplier effect. So a number less than 1 is going to be less probable. A number greater than 1 is going to be more probable. So for example, it is 1.5 times as probable for a male to strongly disagree if they have not participated in science club. Okay. I will say that these results don't really mean anything because the classification rate, the rate that compares the amount of predicted answers versus the actual answers, the predicted accuracy is only 50.5%. That means it's a 50-50 chance. So these results don't really mean anything, but it's still interesting to look at. So let's go ahead and take a look at the sex category here. So we're again looking at males because female is the baseline, and males are less likely to agree, disagree, and strongly disagree compared to strongly agree overall that science is a useful career. For science club, it's interesting that there does seem to be a line between agree and strongly disagree, where they are less likely, males are they're less likely to agree and more likely to disagree and strongly disagree. And then science competitions, they are less likely overall. And then summer science programs, you've got less likely and then more likely to disagree. So those are kind of a little bit iterative because they're saying the same kinds of things. Okay. And again, the data for this was all the non-answers were taken out. So if all the variables had been filled out, this is what we pulled. So there were several deleted data points. So for further investigations, I think we need to take a look at the stats specifically that these individual extracurriculars are saying. So for example, First Robotics from Brandeis University, they're reporting specific survey results. And I think those need to be investigated a little bit more and then see where the follow-up is on those. I also think that there is an important difference in science competitions between a quiz bowl format and a project-based format. A quiz bowl format would be something like teams or other regional, local science competitions. I know Washington University has a Battle of the Burets where different schools compete for chemistry, AP chemistry knowledge, versus project-based, which would be the typical science fair idea, or some of the events in Science Olympiad where they do a nature of science activity, and it's a longitudinal thing, or in Science Olympiad where they build a project that's supposed to meet certain design specifications. And then there's also university level extracurriculars. Where role does that play? Do students who participate in university extracurriculars stay within their major for longer? And does the gender ratio difference change in a university level? And how does that gender ratio difference affect if women or minorities stay within the program or not? And then there's always this issue of causation and correlation. Do students participate in science because they're awesome, or by participating in science extracurriculars, do they develop the sense that they are awesome and want to continue to do more? Where does that self-efficacy generate, and how do we get students to choose to take the risk to be a part of a science club or a science competition? Because I feel if they choose to take that risk, they're going to get those positive benefits even if they're not successful competitively. Thanks for your time.